Okay, today we're going to work on our third tab of the foldable that's on probability, and that's Unit 12. And the tab's called and, or. I believe we're going to spend 2 days on this, so save a little bit of room from today to do it for tomorrow. But again, this is going to be the third tab and, or on probability. Okay, we're going to talk about probability that deals with and, or. Today we're going to focus on the or one. So in general, though, when you're using the word and, when you're talking about probability, when you find the probability of something and something else, you're really talking about two things happening at once. Okay, so it's important to understand when you have an and statement, you multiply two probabilities together. Okay, today we're going to focus on the or statement. So you're finding your chances of getting one thing or another, so you can get either one. And it's important to understand when you are doing the or statement, you end up adding. Okay, so that's what we're going to talk about. So this is one event. Notice how this says one event. We're only talking about one thing happening. You can draw out a 2 or a 5. So you can draw out one of two things or multiple things. So one thing's happening, you just have different choices of something you can get. So that's why it's called an or statement. Go ahead and write down, okay, this formula, and I'll talk about it a little bit. This formula can get a little bit tricky, but I'm going to show you how to logically think about it first. The only harder ones are when you have a table. Okay, so we're going to use this formula on an easy one, and I'll show you why you need to actually have the formula. But just so you know what this means, find the probability of A or B. You're going to find the probability of A plus the probability of B and subtract the probability of both of them happening together because they overlap. Okay, they're going to overlap, and I'll show you with an easy example here in a minute. Okay, we're going to do a few easy examples. I'm going a little bit out of order, so don't pay attention to the 6, 7, 8 as far as the numbering up here that you see right here, because I'm going to go a little bit out of order. I think it's a little bit easier to explain this way. So let's talk about simple probability that we've been doing. So it says, suppose I filled a hat with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So numbers 1 through 10. It says, what is the probability of getting a 2? So remember, anytime it has a p, or you're finding the probability, you're going to have a fraction answer. Okay, so there's 10 numbers up here, so the total number of outcomes I can draw are 10. That always goes on the bottom. And the chances of getting a 2, how many 2's are in the hat? Well, there's 1. So you have a 1 out of 10 chance of getting a 2. Okay, so that's pretty easy. That's basic probability. Okay, number 7 up here, probability of getting a 2 or a 7. Again, this is another one that's logical. Okay, you have 10 numbers up here, so that's going to go on the bottom. And you can get a 2 or a 7. So how many options do you have? You have 2 options. You can get a 2 or a 7. So you have a 2 out of 10 chance of getting a 2 or a 7, which is 1 out of 5. So yeah, it's still pretty logical. Even the last one here is logical, but I'm going to show you stuff overlaps. And that's when this formula comes in handy, is when you have stuff that overlaps. So the last one says, what's the probability of getting a multiple of 3 or an even number? So let me first write out multiples of 3. So multiples of 3. Okay, so if you look up there, out of that group, multiples of 3 are 3, 6, and 9. Or it says you can get an even number. So let me write out the word even. And so the even numbers from that group are 2, 4, 6, 8, and 10. Okay, so out of the 10 numbers listed up there, I know I can get a multiple of 3 or an even number. If you count the numbers I've listed, you have 1, 2, 3, 4, 5, 6, 7, 8 numbers that are up there. So you might think 8 out of 10. But that's not true because 6 was listed twice. Okay, you can't count it twice because it's only in the hat one time. So I need to cross it out. That's where they overlap. So really I only have 1, 2, 3, 4, 5, 6, 7 numbers out of 10 that I can draw out of the hat, okay, that are going to be a multiple of 3 or an even number. Let's go ahead and use the formula so I can show you how you'll get the same answer. So that formula, let me just write it down again. It's the probability of A plus the probability of B minus the probability of A and B. So here's how it works if you weren't sure. Okay, this one's pretty logical because you can actually see the numbers, but if you have to use this formula, the probability of A, that means the probability of the first thing happening, so getting a multiple of 3. we know that there are 3 numbers that are multiples of 3. The probability of B. Okay, we know there were really 1, 2, 3, 4, 5, 5 numbers that would be an even number. So again, originally you get 8, but you got to subtract where they overlap. So the probability of A and B, so that's where they both overlap, where A and B, where you have a multiple of 3 and an even number, that number is 6, so you have one of those. So that's why you subtracted away where they overlap. And that's how we got that top number 7. Okay, so I knew there were 7 numbers out of 10, okay, where I could get a multiple of 3 or an even number. But again, that's only where they overlap. That's only where they overlap. And if you have stuff in front of you, like up here where I can look at it, you can get this right. So let's look at some where it's a table. Those are the harder ones where you got to use that formula. Okay, if you remember previously, here's a table that we did yesterday, okay, when we were doing probability. So you may want to copy it down, or you can just put a note that you're going to reference it in your foldable if you already have it copied down in your foldable. But it's already filled out. Go ahead and at least write the questions down, okay, that are on here. But we'll go ahead and talk through these questions, okay, when you have a table. But on here, I'm going to probably have to use the formula on the or statements because they are going to overlap. So let's start with number 1. Okay, number 1 is not a probability question. It just says how many men or basketball players were there? Okay, how many men or basketball players were there? So the key word that I have here is or. Okay, or. So on this one, I have a total number of men, a total number of basketball players, but they overlap. Okay, they overlap. There's some men that play basketball, so I can't count them twice. So yeah, I'm going to use the formula. So again, I'm going to write the little formula up here. So probability of A plus the probability of B minus the probability of both of them occurring, A and B. Okay, and I'm just going to go ahead and do that for number 1. So it says how many men or basketball players were there? So let's look at men. The total number of men was 21. The total number of basketball players, if you go straight down, is 30. And so I don't count them twice. Where they overlap is where we have male basketball players. Okay, so I don't want to count them twice, just like I showed you in the last example. So 21 plus 30 minus 6. Okay, 21 plus 30 minus 6, that ends up being 51 minus 6, which is 45. So there should be 45 people that fall into that category. Okay, so I'm going to go ahead and erase what I circled up here so you don't get confused. Okay, the next one, it says how many women soccer players were there? Well, notice how there's not an or statement, okay, and it's not multiple events. It just wants to know how many women soccer players there were. So again, I just find where women and soccer intersect. So that answer should be 5. That's an old question like we did yesterday. Okay, so that one's 5. So let me erase that. Number 3, how many basketball players or women were there? So again, this is another or statement. Okay, so I'm probably going to have to use that formula up there. So let me erase what I wrote before. Okay, because people are going to overlap, and I don't want to count them twice. Because there's basketball players, and there's women basketball players. So I don't want to count that group twice. So if we go up here, the probability of A, that's how many basketball players there are. So in general, how many basketball players are there? There's 30. Okay, how many women are there total? 29. So I don't count the group twice. I need to go ahead and subtract out women basketball players since I already counted basketball and women. So women basketball players is 24. And that should give me the total number of people in the group that follow that order. So 30 plus 29 minus 24 should be 35. Okay, so 35 for that. Our last 2 at the bottom, the last 2 examples, they're probability, so I am going to have to make a fraction. So again, let me erase what I wrote down up here. Both of them are or statements. Okay, so I'll probably have to use that formula. In general, though, whenever I see a P, probability, I know it's going to be a fraction answer. The total number of people surveyed, if you remember, it says at the bottom that is 50. I'm going to go ahead and put that at the bottom of my fraction to start out. Okay. So let's start with the first one. So number 4, it basically states what's the probability that somebody is soccer, okay, or a male. So soccer or a male. So again, since it's an or statement, they can be soccer or a male. So the probability that somebody is soccer, okay, how many total people are doing soccer? That is 20. The probability that they are male, I'm going to look at the total number of males. So that's 21. And I'm going to subtract out where they overlap so I don't accidentally count the same group twice. And so that's where I'm going to have male soccer players. So men that play soccer is 15. So I don't want to count them twice. Okay, so I'm going to go ahead and put that up there. So when I go ahead and total that up, I end up getting 26. So 26 out of the 50 people fall into that category. If you reduce that, that ends up being 13 over 25. Okay, 13 over 25. Okay, the last one. Okay, the probability of somebody playing basketball or being a woman. Okay, again, let me erase this. So how many people play basketball? Total number is 30. How many people are women? 29 that were surveyed. And again, I'm going to subtract where they overlap because they do overlap because there are women that play basketball. So women that play basketball is right here. That's 24. Okay, so that should give me that total. So 30 plus 29 minus 24. And I end up getting 35. So 35 people actually fall into that category. And if you reduce that fraction, that ends up being 7 over 10.